In the previous video, we talked about finding the domain and the codomain of a function. Now let's talk about finding the range of a function. Let's say you're given a well-defined function, f, from x to y. The domain of the function is x, the codomain of that function is y. And suppose you need to compute the range of f. There's two times when that is an easy task. The first is if the domain of the function is finite and small. Often we'll write the function using arrow notation, and then the range of the function is the set of values that the function takes on, or in other words, it's everything that has an arrow pointing to it. So in this example, the range of this function is equal to the set B, C, D. And in the second example, when we've written it in two-line notation, the range is the set of possible values that the function takes on, 1, 2, 3, because those are the values in the second row of this two-line notation. Another example, when it is not too complicated to find the range of a function, is if the function is extremely well behaved. So let's look at this function. The function from the natural numbers to the natural numbers, where f of x is equal to 2x plus 3. We'll start plugging in the values. 1, 2, 3. F of 0 is equal to 3. F of 1 is equal to 5. F of 2 is equal to 7. F of 3 is equal to 9. And we start to see a pattern that the range of this function is going to be equal to the set of odd numbers greater than or equal to 3. So because this function was very well behaved and we understand the domain very well, then the range is something we can calculate. Here's an even more silly example. Here we have, let B be the set of buildings in New York City, and we're going to define a function d from B into the natural numbers, where we define d of a building to be the number of live dinosaurs in, oops, this should be a lowercase b, in that building. Well, how many live dinosaurs are there in the building? Well, no matter what the building is, there are 0 live dinosaurs. And so the range of this function is going to be equal to the set 0, because that's the only possible answer for this function. All right, now let's talk about when we're not in one of those two simple cases. We will need to rely on what the definition of range is. So remember, the range of a function is the set of all little y in the codomain, where y is equal to f of x for some x in the domain. So let's look at this example. Let A be the set of all animals in the Bronx Zoo. We define the function L of A to be the number of legs of an animal in the Bronx Zoo. We recognize that numbers of legs are always going to be integers. And not only integers, positive integers are 0. So the codomain of L is the set of natural numbers. Well, the range of L are the set of actual numbers of legs that some animal has. There will certainly be a 0, a 2, and a 4 in there. Maybe we should consider an octopus to have 8 legs. And how many legs does a millipede have? Well, what you'll have to do is you'll have to do an inventory of all the different legs of animals in the Bronx Zoo, and you'll have to write them out. Now, probably nothing has more than 1,000 legs, so that's going to give you a restriction on what this set is. And maybe there's some animals that have fewer legs than they started off with, or have more legs than one might expect. And so maybe there's an animal with 1 leg. Maybe there's an animal with 6 legs or even 9 legs. You'd have to go through and do a full inventory of the animals at the Bronx Zoo. Let's stay with the animals in the Bronx Zoo, but this time we'll define a function that's the weight in kilograms for each animal in the Bronx Zoo. The codomain is going to be real numbers that are at least 0. And then, well, the range of W is equal to the set of all weights of any animal at the zoo. We've got animals that have very small weights. We've got animals that have very large weights. And this would be the range of the W function. It would be the set of all possible weights where these numbers, if there's a number in here that's 100, that's telling us that there is at least one animal that weighs 100 kilograms. There may be multiple animals that weigh 100 kilograms, but we're just saying that there is at least one animal. Let's do another pair of examples. Let's define capital L to be the set of letters in the English alphabet. We can define a function f from L into the natural numbers that converts the letter to its numerical position in the alphabet. So we're going to define f of A to be equal to 1, f of B to equal to 2, f of C to be equal to 3, etc. What's the range of this function? Well, we know that there are 26 letters in the alphabet, so we expect the range to be the numbers from 1 up to 26. Now let's do something a bit more complicated. Let's define W to be the set of all English 5-letter words. We're thinking Wordle. We'll define a function T that takes in a word as input and outputs the sum of the letter values over all letters in this word. So T of apple, the total letter sum of the word apple, would be f of A plus f of P plus f of P plus f of L plus f of E. And we translate each of those letters into numbers. A was 1, P is 16, P is 16, L is 12, and E is 5. We add up those numbers and we get the total sum of 50. Well, the range here is going to be the set of all y in N such that y is equal to T of x for some word x in W. That's probably the best way to describe this. We could probably write a computer program to take in the set of all 5-letter words, calculate this value for each of them, and then we would see that these numbers is going to be some subset of the lowest value would be if we had 5 A's. I don't know if this qualifies as an English word, but in that case this would be 5. And then if we had a B in there, we would have a sum of 6. And the maximum that this could possibly be, which is definitely not a word, unless you talk about falling asleep, that would be 26 plus 26 plus 26 plus 26, which is 130. The range of this function is some subset of this, and it's almost certainly a proper subset of these numbers. All right, that's it for this video. Take care.